Hello wonderful person, this is Anton, and today we're going to be discussing earthquakes. And more specifically, can we actually predict earthquake, or at least forecast earthquake to some extent? With a lot of this based on a relatively recent study that actually discovers something really intriguing. But the thing is, I was planning to make this video much earlier, but decided to postpone it for a few months because of that massive earthquake in Turkey a couple of months ago, back in February of 2023, that would make it appear like I'm trying to abuse the algorithm and use this strategy to get the views. Not at all what I'm trying to do here. I do actually want to explore this scientifically, or at least to some extent, and this is actually just going to be part 1 of this video, because the next part is going to focus on something a little bit more specific. The prediction about this particular earthquake in 2023 that was made on Twitter by someone from Netherlands, and I guess to some extent went viral because the earthquake did happen 3 days later. But the thing is, this particular person was using, for the lack of better words, astrology to predict everything. But we know that this is not the first time someone was able to predict earthquakes, and this is not the first time that someone used the orientation of planets or the moons in order to make these predictions. But so far, every study in the last few decades discovered that these are just one-off events, with only something like 5% of them being correct. 95% of these predictions will always end up being incorrect, and lead to problems we're going to be discussing in this video a little bit later. And so, as you can see from USGS right here, the question, can you predict earthquakes, is a very definitive no. But there is a way to maybe forecast them, kind of like weather. And a recent study that you can find in the description discovers something else very specific, and potentially something groundbreaking in allowing us to forecast them even better. And so in short, as of today, there is no definitive way to predict earthquakes, no matter where you hear it. There are maybe occasional hits when someone gets lucky and actually does make a prediction that comes true, but there's actually only one known case where one prediction was able to save lives. In reality, most of these predictions end up creating a lot of uncertainty, a lot of panic, and more importantly, huge loss of money. But I guess the question is, why can't you actually physically predict earthquakes with 100% accuracy? Well, let's start with the obvious. Right now I can make a definitive prediction that there's going to be an earthquake somewhere around Indonesia in the next few days, and it's going to be relatively powerful and felt by a lot of people. Now that's a pretty bold statement, but it's most likely correct because on average there are a lot of earthquakes in this region. Statistically speaking, because Indonesia is located inside the Ring of Fire and contains tens of thousands of different islands, in the next few days at least one of these islands is going to experience an earthquake. As a matter of fact, here's one right here that just happened a few hours ago from when I'm making this video. You can use the map from USGS in the description below to discover the earthquakes in the last 24 hours. But the question is that actually useful? I'm basically just stating the obvious. I'm predicting something that we know is going to occur, almost certainly, we just don't really know where or what effect it's going to have. Okay, well that's fair. But obviously if I predict a powerful earthquake, that might be kind of useful. It could save a lot of lives, it could prevent tremendous damage, and maybe even avoid unnecessary destruction. But more powerful earthquakes are usually exceptionally difficult to predict, and even forecasting them so far has been really challenging. And mostly because of the mechanism that produces earthquakes on planet Earth. It almost always involves some kind of a strain buildup, where the friction from two different plates accumulates to the point where when it snaps, it releases a tremendous amount of energy. Something that's pretty much driven entirely by friction between two different plates. Which is actually really intriguing because by reducing this friction one way or another, you can technically trigger the earthquake much quicker. This is something that happened right here in South Korea a few years ago, when completely by accident, one of the geothermal stations that was actually using superheated water to try to create energy by heating the water deep in the ground and then bringing it to the surface to drive a turbine, ended up reducing the friction so much that it basically triggered one of the first confirmed human-made earthquakes. This was in the city of Pohang. An earthquake with a magnitude of 5.4, pretty much in the exact location as this geothermal station, using enhanced geothermal system that pumps water deep into the ground. And so because all of this is based on the buildup of friction, with the friction itself build up as a result of motion, to some extent this already presents us with a way to possibly forecast earthquakes. We can actually use millimeter scale precision GPS technology to keep track of motion of the plates. National Science Foundation has this intriguing explanation along with a video on how all of this works, but in short, even using the tracking, it's still basically impossible to predict when the actual snapping occurs and when the friction reaches the point where things become too unstable. But forecasting, as I mentioned, is still possible. especially by combining various observations and the data from previous earthquakes in order to then create probability-based forecasts. Once again, USGS has a lot of these on their website with a lot of detail and a lot of analysis. Here's one about California. But in reality, most of these predictions are never really above 60%. And specifically, they don't really tell you when it's going to happen. So here, for California and specifically for San Francisco, a chance for a large 6.7 or greater earthquake is about 72% in the next 30 years. But that doesn't really tell us anything. I mean, it does tell us that it's going to happen, it just doesn't really tell us when, or even if it's going to affect everyone at the same time. But despite of this, the scientists are always looking for more signs, and specifically more precursors, as they're known, in order to improve these statistics and in order to see if we can actually take this to maybe 90% or even higher. For example, the 2011 Tohoku earthquake, that was 9.0 in magnitude, did actually show certain precursory events. Some of them were foreshocks, or tiny earthquakes for days before the big one happens, and some of them involved sudden movements of nearby Earth's crust, which was picked up by GPS. Something similar was detected with the 2014 Chile earthquake that was also very destructive, and of course with that Turkey earthquake that happened relatively recently. But foreshocks and the sudden movement of crust underneath is once again not enough to definitively predict a powerful earthquake. We still need to have more evidence and more rigorous research. And we definitely cannot rely on some person on Twitter making predictions and basically becoming a new prophet. And there's a really important reason for that, based on previous cases from various countries, including cases where people were actually convicted of manslaughter as a result of poor prediction. This actually happened relatively recently, in 2009 in Italy, and 7 different scientists and technicians were eventually convicted of manslaughter because they were blamed for not being able to predict earthquakes that ended up killing approximately 300 people. Although the reality is that they were too confident in stating that it's not going to happen, or if it did happen, it's not going to be a serious earthquake. Had they said nothing, nobody would blame them for anything. Something similar happened in China back in the 70s, with several Chinese scientists getting in trouble for not predicting something. But more ironically, in 1999, China introduced new regulations intended to basically stop false earthquake predictions, mostly to avoid panic and to avoid mass evacuations that started to happen everywhere. And that's basically the important question here. How do you avoid making predictions that might cause panic and destruction because people are trying to leave the city, or make predictions that say something the opposite but then the earthquake happens? So here it's basically a kind of a game of risk. You can technically even summarize it as this. If there is an earthquake and you predict it to happen, notifying everyone, you might end up saving a lot of lives. But if you say something but there's no earthquake, this might end up causing a lot of panic and economic disruption because of this false alarm. And there's a really famous case that illustrates this really well. In 1976, a physicist, Brian Brady, that worked for US Bureau of Mines, made a series of predictions that there's going to be a potential earthquake anywhere between 1981 to maybe 1988. With the prediction being made based on the study of rocks and how they fracture, and the previous earthquakes in this region. Now you can actually read a little bit more about this in this article right here, once again in the description below, but in a nutshell, following his predictions, after years and years, pretty much nothing happened. And just as a joke, one of the headlines in one of the newspapers in Lima even read, "No pasa nada." Nothing happens. The population of Lima passes a quiet Sunday. And this was basically just a joke, suggesting that all of these predictions were sort of wrong. As a matter of fact, the further analysis suggested that this region ended up losing approximately $100 million in revenue that would have come from tourism. Once again highlighting the difficulty of predicting earthquakes. And intriguingly, even the most scientific experiment related to the Parkfield earthquake ended up making a completely wrong prediction. Here the prediction was that the earthquake is going to definitely happen with a 95% chance anywhere between 1988 and 1993. Here's what all of this looks like as a simplified graph. And as you can see from this correlation, it looks almost certain. I mean, why would you think that it's not going to happen? Especially because these events seem to occur approximately every 22 years. Yet 1993 came and nothing happened. 1994 came, nothing happened. 1995, 1996, and so on. As a matter of fact, the next earthquake here happened in 2004, 11 years after the original prediction. This was an earthquake with magnitude of 6. But more importantly, this particular earthquake had absolutely no precursors. No signs that it's going to happen, no smaller earthquakes before it happened, and there was no way to know that it's going to occur. And so for basically 11 years after the original prediction, there would be no way to predict that it's going to happen on September 29th of 2004. And like I mentioned, this was the most scientific approach ever taken, involving several studies, involving a lot of investigation and analysis, and involving some of the most advanced detectors we currently have. And so even though the experiment itself is considered to be a success, the prediction was definitely not successful. And so the reality of predicting earthquakes is obviously very complicated. Not all of them have precursors, with only 1 in 20 earthquakes having a certain type of a precursor that other earthquakes might not have. But you do increase the forecast chance if you combine all of the precursors that we are aware of, including some that have not been scientifically studied very well. For example, we know that animals, in some cases, can sense earthquakes before they happen. It's possibly related to their ability to sense the magnetosphere of the planet, although for now that's just an assumption, but approximately 130 different species seem to show evidence for the change in behavior before earthquakes happen hours or even weeks in advance. This hasn't really been studied that thoroughly yet, but the actual signs are definitely there. The other potential sign is a radioactive gas known as radon. You might already know that this stuff is actually everywhere and it's basically seeping from the planet at all times. Technically, this is actually the biggest contributor to radiation that we all receive on a daily basis. Fun fact, or I guess scary fact, if you live on a first floor or in a basement, chances are you're actually breathing in a lot of this gas at all times, way more than anyone else. But I guess don't be too scared because it's still a relatively low amount. Anyway, we know that there is a correlation between earthquakes and sudden increase in radon in certain locations. Now it's probably because obviously the crust opens up and radon gets to come out much more frequently, but the actual correlation right now is very patchy and it's impossible to use this as a predictor for a specific location where an earthquake might occur. There's also a correlation between ultra-low frequency magnetic anomalies, or electromagnetic anomalies, and earthquakes in certain locations. And the explanation here is most likely in regards to quartz, the mineral present inside the crust that when disturbed will often produce electricity. We call this piezoelectricity. This is how various quartz clocks work as well. And so if a lot of this quartz is disturbed, it can produce certain electromagnetic phenomena. But the exact nature of these phenomena and how they can be used to predict earthquakes is once again currently unknown. Likewise, there seems to be a connection to various ionosphere disturbances and certain types of aurora, but the exact relationship here is not particularly known either. Here, some studies actually show that it's probably more related to solar activity, which can then maybe somehow influence the amount of earthquakes on the planet, suggesting that aurora in this case are not really connected to earthquakes and have nothing to do with the activity in the crust. There's also an unusual correlation between underground water temperature that seems to actually change before major earthquakes. Now this we can definitely measure using satellites, and in the past, studies have suggested that this is maybe a potential way to increase the chances of successful forecast. But obviously this would have to be used along with other different predictors, because water temperature can technically change for other reasons. And then naturally there's maybe a relationship with tides and the activity from the moon, because obviously it does exert a lot of power on our planet, but so far the correlations studied previously have been actually kind of minor. You can check out the link in the description by USGS once again, that provides a little bit more explanation. So these are just some of the potential ways to forecast earthquakes. None of them are definitive, but together they might actually increase the chance quite dramatically. And now we have a completely new way that was just recently discovered. And this involves something we understand pretty well: cosmic rays. There seems to be a direct correlation between seismic activity and the intensity of cosmic radiation very close to the location of the earthquake. This was based on the data from the CREDO, or Cosmic Ray Extremely Distributed Observatory, a project that basically uses various smartphones on the planet to try to collect the data on cosmic rays, and all of the data from CREDO, along with the locations and the observations of cosmic rays in those regions, were combined with various data on earthquakes happening on the planet. And turns out that ground-based detectors see changes in the number of secondary cosmic rays, such as muons, in locations where earthquakes occurred. And in this case, the solar activity was taken into account, so it's probably not the activity from the sun that's responsible for these changes. Instead, what the scientists believe is happening here is probably connected to what's happening inside the planet and how the magnetic field of planet Earth is generated. Today it's believed the magnetic field is generated inside the outer core, as the liquid iron inside sloshes around, producing various eddies. This then produces the magnetosphere of the planet, and this protects us from various radiation from outer space, and that of course includes cosmic rays. When the magnetosphere changes in power, that's when the amount of cosmic rays reaching the planet increases as well. And so here the scientists believe that maybe certain large earthquakes are actually associated with disturbances of the flow of matter inside planet Earth that then create disturbances visible in the magnetosphere through the detection of cosmic rays. Or just to rephrase this, powerful earthquakes might have a correlation with some kind of an activity inside the outer core, which then affects the magnetosphere and which then can be visible through radiation coming from outer space. So it's not that the cosmic rays in this case cause earthquakes, but instead the amount of cosmic rays increases because of the change in magnetosphere, with the change itself occurring inside the planet. And intriguingly, this seemed to apply to all earthquakes with a magnitude of 4 or higher. And more importantly, this was only visible when you shift the data by approximately 15 days forward. Or in other words, you first observe these unusual magnetic correlations or the increase in cosmic rays, and then 15 days later, there might be an earthquake. So in some sense, this could be one of the bigger precursors, assuming that follow-up studies find similar results and actually do discover that this is what's happening here. Although unfortunately, this still doesn't mean that we can directly pinpoint the location where earthquakes are going to happen, or when they are going to happen either. So far, a lot of these correlations were only able to predict a general location and generally occurred approximately 15 days ahead, but not always. More intriguingly, they also discovered an unusual periodicity that seemed to be approximately 10 to 11 years long. But unlike the solar cycle that's the same length, it did not seem to actually align with it. Here, the 10 to 11 year periodicity had its own cycle independent of the sun. At the moment, it's actually unclear why this is happening. And then they also discovered some other unusual periodicities that cannot be explained. Or basically, there are certain periods when there are more earthquakes and more cosmic rays compared to other periods. But in this case, the current factors are unknown. And so in some sense, this means two things. One is that there might be some influences from something in the solar system that cause planet Earth to experience these unusual periods, but also that we can technically use planet Earth as a massive electromagnetic detector to potentially find things in the solar system that would be invisible to us otherwise. Nevertheless, because the link in this case seems to be very strong, the correlation here was of sigma 6 strength. At the moment, this actually is a pretty intriguing discovery that definitely needs to be investigated a little bit more. What exactly is happening between this link of cosmic radiation and the seismic activity on planet Earth? And what exactly can we learn from this in order to maybe forecast earthquakes better? So definitely intriguing stuff. But before I finish this video, I also wanted to obviously state the kind of obvious. Even though we cannot predict earthquakes, as the old wisdom goes, it's not the earthquakes that kill people, it's the buildings. And so the best way to protect everyone is to construct buildings that are meant to withstand earthquakes in locations where earthquakes are very common. Something that's obviously done in countries like Japan, but something that was unfortunately not done in countries like Turkey. And so even though we might never be able to predict earthquakes, and the technology might never reach that point, we already have technology to build buildings to withstand most earthquakes. It just takes a little bit of extra effort on the part of the government and the companies responsible for the construction. But anyway, this is a pretty intriguing topic, so I'm definitely going to come back and explore it a little bit more. And we'll also talk about some other unusual predictions and discoveries, and some other cases that I did not get to explore in this particular video. Mostly because it's already getting pretty long. On that note, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.